Okay, students, so we're going to be looking at capsule tutorial questions. And let's look at question number 1. Okay, so this is the data that you'll be using to do the calculation. And we are going to be looking at the gross weight and the net weight for each capsule. We're going to do 40% excess to account for compounding loss. And least weighable quantity is not applicable to this question. So we are now going to be interpreting the prescription. MFT, 1 capsule per dose, indicates that each dose will be in 1 capsule, and the dose is going to obviously come from the signature because we don't have any DTD or MITI. So it's going to have to come from the signature. The dose says 97 milligrams per meter square in 2 divided doses. In 2 divided doses means that when you calculate, as we have seen here, the dose per body surface area, which we got is 20 milligrams, it means that that 20 milligrams is given in every 24 hours. It is divided in 2 divided doses, either every 12 hours or 2 times a day. So that means each dose is going to be 10 milligrams. So the total number of doses is going to be 1 dose times 2 times a day times 3 days, according to the signature, and that gives you 6 doses. And if each dose is 10 milligrams, it means that each capsule will have 10 milligrams. We calculate that we are going to be we are going to be sending 6 capsules, so we do 40% excess, and that works out to be 9 capsules. When we calculate the total drug needed, that works out to be 90 milligrams. Now that we know that we need 90 milligrams for the total 9 capsules we're calculating for, we are now going to be using the um, the data that's presented here to determine how much starch is displaced by the 90 milligrams of drug. We know that 244 milligrams of the carbamazine powder occupies the same space in the capsule as 233 milligrams of starch. So therefore, we're expecting that 90 milligrams of drug will displace 85.94. Now, students may want to do the calculation per capsule, but you have to remember now, at the end, you're going to have to multiply by the number of capsules you are calculating for. So we determined the number of starch that will be required to fill 9 capsules alone. We got that to be 2097. We subtracted the displaced starch from that amount, and that will reveal the amount of starch that you're going to combine with the carbamazine powder in order for each of those capsules to be elegantly filled and look nice and elegant. The gross weight is going to be the weight of the powder plus the shell. So in order for us to get the net weight, we have to add 90 milligrams, which is the drug, plus the starch divided by 9 to give you the amount of powder that will be in the capsule. To get the gross weight, which is the weight of the capsule shell plus the powder, we add the weight of each capsule shell, which is in the table here, 46 milligrams, and you add it to that of the powder. And this will be the gross weight of your filled capsule. So let's look at question number 2. And this question requires you to show calculation for compounding 2 active pharmaceutical ingredients in each capsule. So we have olmesartan and hydrochlorothiazide, right? And hydrochlorothiazide is shortened or abbreviated as HCTZ. The difference between the calculations we have been doing so far in capsules is that we are dealing with not only the pure powder, now we're dealing with tablet powder. Again, we're going to look at the gross weight, the net weight for each capsule, and going to calculate for 40% excess to account for compounding loss. And as usual, least weighable quantity is not applicable. First, we're going to interpret the prescription. So you have the olmesartan salt, 40 milligrams, hydrochlorothiazide, 25 milligrams, and directly below that, we have MFT2 capsules. It means that when we have MFT2 capsules, it indicates over or in two capsules, you're going to find two capsules together. We're going to find 40 milligrams of olmesartan and 25 milligrams of hydrochlorothiazide. This means that you're going to have to divide by 2 to determine the amount that will be in each capsule. So when we do that, we get olmesartan has 20 milligrams per capsule as a dose, and hydrochlorothiazide as 12.5 milligrams per capsule as a dose. Now we need to determine how much or how many capsules we need to prepare. Now, although the signatura is there, below the signature we see MITE 5 capsules. So it simply means that we are going to not say we're going to ignore the signatura, but as was discussed throughout this module, we are going to really focus on the MITE or the DTD. If MITE or DTD is not there, you're going to have to focus on the signature to determine the number of capsules to prepare for. So we're preparing for 5, we're sending 5, but we're preparing for 7 because we did 40% excess. And you will see the total amount of both ingredients there for the 7 capsules. So once we have identified or calculated rather the amount of each of the active ingredients that will be required for the entire 7 capsules, we need to ask ourselves what's the source of the ingredient. And for olmesartan, it's a pure powder, so that's fine. We just go and wait. But the hydrochlorothiazide, no, it's not the pure powder, but tablet powder. Specifically, hydrochlorothiazide 25 milligram tablet powder. So what they did was that you're going to get the tablets and you're going to crush them, make the powder. So we need now to determine how much or how many tablets will furnish us with the 87.5 milligrams of hydrochlorothiazide that we need. And we got 3.5 tablets. So it means we're going to have to crush some tablets to get the 3.5. We're not here cutting tablets in half like that. We want to be accurate, so we're going to crush more than we need. So in this case, we're going to crush 4 tablets, and then we're going to weigh the tablet powder that's equivalent to the 87.5 milligram of drug, which happens to be 378. Where did we get the 378 from? We got it from the weight of the tablet. So the average weight of each tablet here is 108 grams. Sorry, 0.108 grams per tablet. So if we know that one tablet weighs 108 milligrams, then 3.5 tablets are going to weigh 378. So the takeaway from this is we're crushing 4 tablets. We're not going to crush 3.5. We're going to crush 4. Obviously, we're going to get more than what we need. And then we weigh the tablet powder that has the equivalent amount of the drug we need. And then we go right ahead to determine the starch that is displaced by each of the drug. So we did it for olmesartan. We know we want 140, and we go back to the table to look for the fill weight for both the drugs, and they are there. It's very self-explanatory. So it means that olmesartan 140 milligram will displace 151.44 milligrams of starch, and 378 milligrams of hydrochlorothiazide 25 milligram tablet powder will displace 344.98 milligrams of starch. We find out how much starch will require to fill 7 capsules alone. We subtract from that the starch that is displaced by the 2 drugs to get the amount of starch we need to mix with these 2 powders. And then we end up with the new formula, which is seen here. We find the net weight and we find the gross weight. Now we're going to look at how to apply the concept of fill volume, and that's for question number 3. So question number 3, the information is here. So here we're not using fill weight, we're using the density information of the powders. So the density information of the powders will be given, which is seen here. Again, we're using a tablet. The source of an active ingredient is going to be the tablet for the acetaminophen. So we need the tablet weight. And of course, another important data that we need is the volume of the size capsule shell that we're using. In this case, we're using size 1, and it has a fill capacity or volume of 0.5 mils. And again, we are doing the same thing that we did for the first two. So we interpret prescription. Always do that first. We assess our prescription. MFT Div 3 capsule. If you remember from our lectures, MFT Div 3 or MF3, whatever number, we're going to divide by that number, whatever is above it. So it means then that across 3 capsules, you're going to have 112.5 milligrams of tramadol and 500 milligrams of acetaminophen over 3 capsules. So if you want to find one, you have to divide by 3. We got that here, right? And we now need to determine the number of capsules to prepare for. How much are we sending and what process are we making? So here the signature is there for 2 weeks, but we have DTD number 8. So we're sending 8 doses, and each capsule is a dose. So it means we're going to be sending 8 capsules. 40% of that is 12. And we calculate the total amount of drug needed for the 12. We need to identify the source of each ingredient. Tramadol is the pure powder, as seen here in the table, density of tramadol powder. The acetaminophen is not the pure acetamin powder, the acetaminophen 500 milligram tablet powder. So we have to now calculate the number of tablets that will furnish us with the amount of acetaminophen that we need for our capsules. And that's 2,000 milligrams or 2 grams of acetaminophen is what we need for our capsule, number of capsules we're sending. So because we have the tablet, we know that one tablet contains 500 milligrams. So we find out the number of tablets that 2,000 milligrams will be contained in, and that's 4 tablets. Now you might be wondering, should we crush 4 tablets, Miss Price? No, we shouldn't. If we crush 4 tablets only, we are not going to get for the total amount of tablet powder because some is going to be sticking to the sides of the mortar and on the pestle. So what we're going to have to do is crush more than we need. So we're going to crush 5. So that means we need to determine what is the tablet weight or what's the total weight for the 4 tablets so that when we crush the 5, we know how much of the tablet powder to weigh. Of course, the tablet weight is here in the table, the average weight, 793. So we know how much is it. It would be for 4, which is this written here. So once we define that, the amount of powder, whether it be tablet powder or pure powder for the 2 drugs, we are now going to use density information to calculate the volume that these powders are going to occupy. So we know density is mass over volume. We know we're using 450 milligrams of tramadol powder and 3,172 milligrams of acetaminophen tablet powder. So we just use the density equation and the density of the powders to determine the volume. Okay? And we determine the volume that these powders will occupy. And the next step then is to calculate the total volume that the 12 capsules will have. What's the capacity of those 12? Remember the table has it. 0.5 mils is the volume per capsule. So multiply by 12 to get the total volume for the 12 capsules. Once we have that, then we subtract the combined volume that powders will occupy, the ingredients will occupy from the 6, which indicates that this is the volume that the starch is now going to occupy. And Once we determine that volume, we can now equate this volume to mass of the starch using the same density equation. So density is equal to mass over volume, just a little transposing. We can find the mass by multiplying the density by the volume there. And this is what we have. So we end up with 1,583 milligrams or 1.583 grams. Write our new formula, determine the net weight, determine the gross weight. And that is all there is to it. So I want for you to just try the questions on your own. Do the first question first. I mean, it's first. Don't jump in the hard one. Do the first question first. Try a hand at it from start to finish. If you're working in groups, all of you worked on it together. Compare your information. If there's anything that you guys need to discuss, you discuss it. Then you look at the video. Okay? I hope this helps you for your test tomorrow and for your upcoming exams. All the best to you. Bye, guys.